Pac-Manians. There's the last page. There's always the funkiest problems that they've got for us, but we're just gonna use the same strategy. We make tables, set it up. Some of them you really could probably figure out without a table, but I'm gonna make one anyway, in case you do need one. So let's take a look at the first one here, number 7, go deeper. Emily has a road trip, or a road map, with a key that shows an inch on the map equals 5 miles of actual distance. She will drive on 2 roads to get to the beach. One road is 7 inches long on the map, and the other road is 5 inches long. What is the actual distance Emily will drive to the beach? Write your rule, the rule you use to find the actual distance. So this is a multiple part problem, but we gotta know, first of all, what's our relationship here? So on top, I would put inches, right? And on the bottom, I'd put miles, okay? And you can make a table just like that. If I go 1 inch, how many miles did they say it was? So I gotta go back to the problem. 1 inch, an inch on the map equals 5 miles of actual distance, and she went 7 inches and she went 5 inches. All right, so if she goes 1 is 5, what's my rule? From 1 to 5, what do I do to a 1 to make it a 5? Well, if I put a little multiplication sign in here, 1 times 5 is 5. So if she goes 2 inches, that's 10 miles, right? And we can just carry that all the way out. So dot, 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 we go to 7, and whoops, we go to 5, and then we'll go to 7, dot, 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 7, okay? Put those in there. 5 times 5 is how much? 25 miles. That's one of the roads. The other is 7 times 5. What's 7 times 5? 35. Put that on there. And am I done? No, because it says for both roads, so I just add them up. 25 plus 35. Right? And 5 plus 5, 10. Right? And then 1 plus 2 plus 3, 6. We get 60. So she went 60 miles in all. Boom. All right. Identify relationships. This one is one of those ones that can get you because it's a lot of words going on here. But to make a shade of lavender paint, John mixes 4 ounces of red tint and 28 ounces of blue tint into 1 gallon of white paint. So these are our starting points. 4 ounces of red, 28 ounces of blue, and 1 gallon of white. And it says 1 there. I'm just gonna put a 1 so I don't forget what it is. All right. If 20 gallons of white paint and 80 ounces of red tint are used, how much blue tint should be added? And then we're gonna write a rule. You can write 2 rules really if you wanted to. But what I'm gonna do is I'm gonna put, usually I would go smallest numbers on top and then to the bigger numbers, but we're gonna look at the relationship to the blue from red's perspective and white's perspective. So I'm gonna put on top red, blue, and then white. Okay. All right. And where do we start? With 4 for red, 28 for blue, and 1 gallon for white. All right. Everybody good with that? If I wanted to make another, I would go to 8, and I would double that to 56, right? And that will be 2. Okay. So the question goes, we go dot, dot, dot all the way down the road here. We end up with 20 and 80. And we got to find out what this is. Okay, that's our missing piece. So I got to find my rules. What are my rules? Well, if I want to go from here to here, 28 is, of course, larger than 4. So my rule is going to be to multiply. What do I multiply 4 by in order to get to 28? So you can divide 28 by 4 and get the answer, or you can use multiplication chart, or you might probably already just know it. But we're going to do what? Multiply by 7. So I put times 7. So 80 times 7 would give me my answer. Okay, and then if I wanted to go from white to blue, what would I do? Well, from 1 to 28, I multiply by, 28. That's an easy one. Okay. So this is either times 7 or this is times 28. So, will they both work out? Well, what's 7 times 8? 56. So I write in here 56. And then I've got this 0 here and I just add it in, 560. I wonder, is 28 times 20 also 560? You know I'm going to do it, so I'm going to write it over here. 28 times 20. Okay. Do I need to even worry about the 0? No. So it's really basically 28 times 2, because I would just put 0, 0, 0. 2 times 8, 16, right? 2 times 2 is 4, plus 1 is 5. I get the same answer. All right? So, set up a table, put things in an order where you can look at it. Remember, where did I look to find my rule? Way over here on this end. I don't want them to go mess with the big numbers. All right, finally, in the cafeteria, tables are arranged in groups of 4, with each table seating 8 students. How many students can sit at 10 groups of tables? So we're going to set it up as groups. Okay. Tables are arranged in groups, so that's one of our categories. All right. Tables, because groups are arranged in tables. So if I have one group, I have 4 tables, groups of 4. Okay. So, and each table seats 8 students. So my last category is going to be students. Do I put 8 there? Do I put 8? Well, there's 8 students at one table, but in each group, how many students are there? Or at each table? There's 4 tables, 8 students. What's 4 times 8? That gives me 32, right? So I'm going to have 32 students. All right, hopefully you can see that. Let me tilt her down just a little bit. Okay, so I've got one group, 4 tables, 32 students, and it goes all the way out, to 10. So if I have 10 groups, what's my rule to go to tables? Multiply by 4, right? So I would have 40 tables. 10 times 4 is 40. And to go to, from one group to students, I can multiply by 32. 10 times 32, that's 32 plus a 0, right? So 320. And what's my rule to go from 4 to 32? Well, it was 8 students per table, so I would times by 8. What's 8 times 4? 32 plus my 0, 320. So what they're trying to get us to do here is to realize there's lots of ways to connect data if they're all in a pattern and they are all related, so you can compare any 2 that you want. That's basically what that's saying. All right, I'm going to scoot you up to the bottom and just give you a quick little look, and then we'll talk homework.